Oh, nurse? Kitu? Oh, hi, Nikki.
Good morning, sir.
Good morning.
The Talukdar sir is, I think he is trying to contact. Yeah.
Jessica.
Okay.
Unmute. Can you
Good
hear
morning,
me?
sir. Yes, sir. I
Yeah,
can hear.
yeah, very nicely.
Good morning, everyone.
Good morning.
Good morning, sir.
Good morning.
Beautiful view behind you.
Oh, is it some book? Oh, okay. This is my new office in home.
But your Japi is also good.
Okay. All right. Thank you.
You know, I'm coming from extreme corner, so almost 4,500 kilometers away.
It feels so good. Technology has brought us
No,
close.
it's very good. No, it's very
And
good. Something, at least we can see, we can talk, we can exchange. That is something very good.
Yeah, only virus has compelled us to do that. It is also good to meet.
And I don't know how far it is going to be to become a part of a system now. I don't think this sort of lockdown, locked in and all, very difficult. It will go like this. You're from the office now or at residence?
No, I am in my residence, director residence. I have made a small office.
Very nice.
I'm not in downtown. I am here in ISST.
Okay. How is ISST now? It's functioning with the minimum staff or it is?
Students have also joined. It's not like they don't have any alternate off one day, then again coming. It's not like that. It's almost 100% kind of thing, except technical officers and office staff, they come on alternate day.
Okay.
But otherwise, scientists and PhD students, they have almost 50% have come back, not all, 50%.
Oh, okay. Very good. So people are there. But overall, how is the situation in Assam?
Positive cases are going like skyrocketing. It's very high.
But if you compare to Kerala, it is less. Because Kerala, every day 200 coming up.
Okay, here it is per day. It is also almost 100. It is coming to 100, no? Almost 100, more than 100 a day. So initially there was none. Almost
Here the problem is coming from Gulf. Other states is not that much.
I don't know what all these people moving to different places. Situation when it is going to improve.
It is, I don't know. It become very difficult now. Very difficult to move out, and you can't do anything now. You cannot move one place to other place.
Yeah. Can you hear me? I'm now connecting to microphone.
Yeah, I can hear very well. Very well. If you have, it's always good if you have with computer attached, then it will be more comfortable. I think you must have that. Instead of using the earphone, if you talk as casually, without keeping this.
Yeah, but sometimes the sound like, okay, let me try. Are you hearing me well?
Just remove it and see.
Yeah, how is it?
Yeah.
Do you hear me well? It's okay?
Very good, very good. Perfectly fine.
Yeah, sometimes it creates problem. Okay, I'm good.
You don't require that.
Background noise sometimes create problem.
No, now it is very clear now. And you feel very comfortable.
Yeah, that's true. That's true.
Because otherwise the ear will start getting heated.
Yeah.
That's why I don't use it, because as such, sit comfortably and talk, that will be good.
Okay, then let us start the 5th day of webinar lecture series. Good morning, everyone. Can you hear me?
Yeah, very well.
Okay, very good morning to everyone. Our today's speaker is Dr. Narayan Chandra Talukdar, and his topic will be research opportunity on bioresources of Northeast India for rural technology generation and societal benefit. Now, let me give a brief introduction of Talukdar sir. Dr. N.C. Talukdar, former director of IASST DST Guwahati and IBSD DBT Imphal, did his PhD from University of Saskatchewan, Canada, MSc from Punjab Agriculture University, Ludhiana, postdoctoral research in University of Jerusalem, Israel, and University of Warwick, UK. He taught and carried out research in Assam Agriculture University, Jorhat for 15 years. He supervised 25 PhD research, 20 MSc thesis dissertation research. He has published more than 100 research papers, 1 international and 1 Indian patent granted, and 11 Indian patents filed and published. Recipient of Canadian Commonwealth Scholarship, FAO Rome Fellowship, DBT Overseas Associateship. For his able leadership of 7 years, IASST backed Assam State Science Award 2019 of Ministry of Science and Technology, Govt of Assam, for excellence in scientific research and carrying the benefit to masses, including among weaker section of society. Now, I request Dr. N.C. Talukdar to deliver his speech. Thank you.
Thank you, Dr. Maitri, for a nice introduction. And
thank you, sir.
Hello, everyone, and good morning. Namaskar. I see 55 participants today. Yesterday, there were about 75 or 80.
Now it will increase.
Okay, good. This, I think I'll share the screen. Okay. Go to slideshow.
Yeah, just come.
Okay.
Just come.
Okay, can you see the slides?
Yeah,
okay.
I can see. Yeah.
Okay. I actually this, oh, sorry, just to go back. The particular topic I chose, research opportunities on bioresources of Northeast India for real technology generation and societal benefit. Some of the viewers this morning may have also listened to some webinar I delivered last 15 days. Last 15 days, I've talked maybe 3 or 4 occasions. But my own hometown, Tihu College, they organized the first one. There were almost 250 participants all across different colleges of Assam. And this last 3-4 talks was on bioresources. And that's why some of the viewer or participants today may find some slides are similar. So please bear with me. This is ISST campus, like I take pride saying, because there was only one building. This was the only building when I came in 2013. And today it's full of buildings. Now coming to this bioresource, actually bioresource are the, you can say, functional part of biodiversity, which means the biodiversity, a part of biodiversity we understand more and human race has used in its long journey to present day of our civilization. And those we understand well, we term them as bioresource. It has become resource for society. And biodiversity includes sum total of all organisms and life ecosystem on this planet. And in fact, bioresource and biodiversity in a way is inseparable. And I'm sure most of you know there are about 36 biodiversity hotspots as per IUCN. And we have, fortunately, in Northeast 2 biodiversity hotspots. One is in Eastern Himalayan hotspots and one Indo-Burma biodiversity hotspot. We are right in the Indo-Burma biodiversity hotspot, sitting right at this moment. And a few features of these biodiversity hotspots, that medicinal and aromatic plant, it's a richest diverse resource of this hotspot. About 95% of this map, medicinal and aromatic plant, is harvested from wild. It's a very peculiar thing. And these hotspots share about 2.3% of the world endemic plant species. Then we have about 250 or more than ethnic communities with rich traditional knowledge. Fishes and insects of edible and therapeutic values are rich bioresource of this region, and a huge unexplored microbial world found in this region. If you give a comparison of the 3rd biodiversity hotspots of the country, Western Ghat biodiversity hotspots, where right now Dr. Unni is sitting, Indo-Burma biodiversity hotspots is in terms of area, in terms of flowering plant, mammalian species, bird species, it's very rich, very high magnitude of diversity. And I also just wanted to throw a slide of based on this bioresource or biodiversity, the human population of 100 crores in 1803 reached 780 crores. Today, this is the latest June data. I think this is 18th June data. And this bioresource, what we have done, about 65% of bioresource from 1975 to 2020 lost from this planet. So humanity has to now, based on less and less biodiversity, bioresource, to feed more and more people. That crop land has decreased, access to safe drinking water has decreased, so it has brought a lot of problem. Now, the bioresource that we have, the research and development that we do has to be more stringent and to meet. And the other scenario you'll find, it's a European picture, a European scenario. You all know this beet, cabbage, sweet corn, lettuce, these are different horticultural crops. Now, about 80 years ago, these were the variety, like in Europe, beet had about 288 varieties, cabbage had 554 varieties, and in a gap of 80 years, the beet variety has gone down to shrunk to 17, cabbage 28. So this is the situation. I mean, this rich crop diversity, varietal diversity has gone down. Now, when we talk about bioresource, like there are you may raise a question like a horticultural crop variety, rice variety, and bioresource. I think there are broadly all bioresource, but my main focus today will be on some high value crops for Northeast India, high value crops, fruits, vegetable. And Northeast is, for production of these, we have abundant land, fertile soil, natural rainfall. We use low level of chemical advantage for organic farming, huge quantity of agricultural residues and animal excreta for production of organic manures. And also other bioresources other than these fruits, vegetable, are the bamboo, agarwood, khair plantation. I'll say a little bit about all these. The city biodiversity, both insect and host plants. Wetland or valley region of Northeast India, mainly Brahmaputra and Barak Valley, has huge diversity of wetland and fish, insect bioresources, and then your fermented food resources, bioresources, tea industry waste. I'll briefly deal on some of the research we have been doing. But, and then to show you some pictures of some, when I talk about rice diversity, where we can treat them as a high value crops as a bioresource, the scented Johar rice of Assam and scented Johar rice of your Manipur. Then the rice bean diversity is huge in Northeast, particularly hilly. These slides is very dear to me. In one district of Nagaland has about 103 rice bean germplasm, and you see the diversity. You can just yourself distinguish them, the variations in them. Like your Capsicum sinensis, I think this name has become now Capsicum assamicum. This is a variety with more than 1 million Scoville heat units that rating, like your Tezpur Defense Research Laboratory, they put it in Guinness World Book of Record in 2007. This diversity of this crop is marvelous. Like then we all eat bamboo shoots as vegetable, and then even it has huge diversity. There are about 17 different types of bamboo shoots diversity we reported in our publication when I was in Imphal. Then citrus diversity is India and world famous, Northeast citrus diversity. Then the Northeast hill states, which cover about 65% of the Northeastern region land mass, they extensively practice shifting agriculture or zoom agriculture, locally known as. It also has or grow large diversity of crop plants, horticultural crop, agricultural crops. Unfortunately, like those, what has gone or vanished from us, we do not have perhaps real-time data as it is in the Europe of what I showed you a while ago in one slide. Now, I also want to show you one interesting publication in Science 2016. These dark blue areas, these are actually roadless area index, high index of roadless areas in the world. And Indo-Burma Biodiversity Hotspot or Sikkim Himalaya hotspots, it falls like it's less accessible. And that is perhaps one reason why we still have rich diversity of crops, animal, plants, because there is no accessible, there is no killing kind of or destruction by humanity, human being. Now, this is what I have already said, that maybe from these hilly terrain, zoom field, diversity must have gone because the whole zooming practice pattern has changed tremendously, but there is no proper record. Again, this to show that I have always said we are rich in diversity, but look at the poverty index, global multidimensional poverty index. India is not doing very well, 0.121, Assam 0.16. So we are a little bit above all India, and Northeast Mizoram is 0.126 to Sikkim, so this is, we have a lot of biodiversity, but bioresource, but we have not been able to use them for poverty alleviation. Now, what I'll do next few slides before I come to a specific group of or specific type of bioresource, I want to give a idea about the system quality. Like last 100 years, this very way we do agriculture, very way we do horticulture, we interfere with nature for production, has reduced the quality of the system, the soil system, if we say, or which quality has gone down to produce better quality food. If soil quality is bad, better food quality cannot be good. Now, this is one example how the forest, green forest are cleared for agriculture and different Latin American countries picture. And this will tell you a real story. The Malaysia and Indonesia palm plantation, Indonesia do much more palm plantation, how the forest, natural forest vegetation has been replaced for oil palm, and doing so, it reduces also soil quality. And the other culprit by which the system quality, soil system quality is reduced is the chemicals, fertilizer and pesticides. There's a beautiful publications in Nature in 2002 that from 1960 to 2000, in 40 years time, the global cereal production from 0.8 to 2 almost has become double, but fertilizer consumption has increased by 8 times. Food production has increased twice, and fertilizer consumption has increased 8 times, 10 to 80. Pesticide in 1940, almost there was no pesticide. I think World War, DDT came first during World War time, not as a pesticide, to prevent the insect bite of the army people. DDT was discovered, but later on it was found to have insecticidal property. And today, after 60 years, we have 3 times increase in pesticides. So these has actually reduced the quality of the system. How we can be sure that quality has gone down. Now, this picture tell you that. Now, with passing years, for getting same level of yield increase, we have to increase the fertilizer application twice or thrice. So now for every unit of fertilizer we use, we get less and less return. This is what it is, because the soil system, the system quality, what I said, has gone. And what determines soil system quality? One most important ingredient of soil quality is the microbial component of soil. In fact, last 10,000 years of agriculture history, or 18,000 BC from today, it summarized the world agriculture history. Now, until 1950, the production was very natural. You grow a crop and there will be some damage due to pathogen. Every year some damage occurs, because without, even in organic farming also some loss always occurs. And then if you look at the microbial contribution, mycorrhizal response, agricultural, natural nitrogen fixation, it has actually from gradually this population of these organisms has gone down, and up to 2010, from 1950, it has gone drastically down, because this is the time where green revolution was in full bloom, and then a huge amount of pesticide fertilizer use that has caused the population of the microorganisms, both diversity and the population, to go down. And our famous Dr. Amos Swaminathan, he talks quite often evergreen revolution, that if we have to have a evergreen revolution, our production stability can come only by restoring the quality of the system, like soil system. And one main component of restoring it is the microbial component. Now, this is a beautiful publications that came in 2014 in Proceedings of National Academy of Science, USA. I want you to put a little bit of attention. This slide is a little bit tricky. This was a very simple experiment. A grassland soil was collected, and they prepared pots with this soil, but the soils were sterilized, means microorganisms were totally removed. And then from another portion of unsterilized soil, this soil was sieved. One maybe known quantity, maybe 1 kilogram soil was sieved through different mass size material. This is 5,000 micrometer. So when you sieve through 5,000 micrometer, that is 1 millimeter, 5 millimeter, then most of the organism, including nematode, fungus, small earthworms even, and fungi, bacteria, everything will go down. And if you use 250 micrometer, then some amount will remain, like smaller organisms, like bigger than 250 will remain. And that way, like what you see here, 1, 2, 3 means they receive material which has been screened out. So the 1 means it receives almost all the microorganisms of the soil, and they put back in one set of pot and let it incubate. That soil is sterilized. So it has been again re-inoculated with the microorganism of that soil. And what you find that with number 1 means those material which comes out with 5,000 micrometer sieve, they have almost all the organism intact. But in the sterilized, this one is the sterilized soil, or which has been sieved through a tiny sieve, tiny pore size sieve, you do not get those microorganisms. This is what happens. And in the same soil, when they look at different soil function like nitrogen turnover, decomposition, carbon sequestration, it also goes down. That clearly indicates that these microorganisms are responsible for releasing nitrogen for crop use, for decomposing plant material, for holding carbon or carbon sequestration. And the other thing happened that it also prevents loss of leaching of phosphorus or nitrate emission. If microorganisms are not there, then emission of nitrous oxide, emission of loss of phosphorus leaching is enhanced. Like this is what particular research very clearly shows how it's a beautifully designed experiment that microorganisms are the main group of organism who is determined soil health. To give you, I hope there are some students, some interesting data. Per gram soil, you have 10 to the 10 to 10 to the 11 bacteria. And on metagenome approach based study, about maximum 50,000 bacterial species. On a culture based, definitely you have about 500 species. And a number of prokaryotes on this planet is on the system 5 into 10 to the 30. And these organisms, they hold about 60 to 100% of carbon in the plant covers of the entire planet. Means microorganisms keep almost equal amount of carbon as the plant, which some may be paradoxical. Then similarly for nitrogen, the microorganism hold 10 times more, microorganisms hold 10 times more nitrogen in their body than do the plant of the entire planet. Similarly, phosphorus, 10 times more phosphorus. So you can imagine this importance of this microorganism in determining quality of system. Now I'm going to give you a small example of my own institute. When I came in 2013, from 2014, I tried to develop 7 acres of land. It was lying a natural land mass with a lot of vegetations. A wetland, during winter months, you get good growth. Summer covered with water. I, of course, always had a dilemma that nature will damage developing, because this is now developed into a bioresource park. Now in the first year, this is what we did. We dug ditches, raised water, your soil, and put an embankment because it was unprotected. So there was fear of encroachment. This is the reference point. This is the main campus plant. Now you'll find in 8/5/2014 to 13/6/2015 how vegetation grow here. This area in less than or maybe about in a year time, vegetation has grown like this. Naturally, the vegetation is coming. And in 2015, 10 October month, the plant has become this big. Now, if you look at this, what I'm saying, when you destroy a system, it's kind of a barren place. Now, in 2014, organic carbon content was 0.15%. And in a gap of 1.5 years, the organic carbon increased to 0.4%. bacterial population increased. Earthworm, there was no earthworm. Earthworm started, it's per meter square area, earthworm. I saw earthworm there. So then when we totally remove the vegetation cover, the system quality goes. This is a simple observation for student. Now I have been keeping record of this. We are going to do systematic analysis, what is happening, and we'll be able to generate a lot of data if the institute continue. I'll not be here, of course. And then when I was talking about Zoom agro-ecosystem, you totally cut a forest, and this is the destruction we bring. And then they, after 2 years of cropping, they leave it they leave it, and then natural vegetation come again. And then again, after 5 years, 10 years, 20 years, they again come to the same place, vegetation. This is how they continue Zoom cycle. The system study has not been done critically or thoroughly in Zoom ecosystem. We launched a program and came up with a lot of beautiful information. Maybe a little bit I'll tell about those to you later. Now, this is what a indigenous people dominated place. They know they never destroy forest completely. They put their crops there, maybe cassava, the aeroids. There is no intervention, no chemical use. And then a little bit of more intervention, still is close to nature. And these are continuous wheat field, lot of fertilizer, single variety, continuous rice field of Punjab, continuous, like a lot of fertilizer, irrigation, and it destroyed the system. Now, when it comes to Northeast India, we use less fertilizer, less pesticides, and agriculture is still primitive kind of. And there is a dilemma whether we should move to very modern agriculture, input intensive agriculture. So when we talk about organic farming, perhaps this region provides tremendous opportunity of organic farming because it helps link the organic farmers can be termed as, or ecologists, real ecologist scientists, and traditional farmers in the search of sustainable agriculture. Means what I showed you, that indigenous people, how they grow, we have to learn from those. So there has to be research why they put a particular system the way they put it. They have not generated any data, but from their intuition, from observation, from generation after generation, they feel it, but you have to generate scientific data. Now, when I was in AU, that is what I started. This is Kharupetia area. It's these farmers, immigrant population, they grow more than three crops, sometimes 4 crops. They use fertilizer. They may look very kind of not sophisticated, but their agriculture is very sophisticated. High cropping intensity, high fertilizer, and they feed a large population of the Northeastern region even. And across Brahmaputra, Bharbogia is another place where some people, this is again a traditional agriculture. At the time of rice, after harvest of rice field, or just few days before harvest of rice field, they sow pea crop without tilling the land and get bumper crop, beautiful crop. And you find a lot of rhizobium nodules. And in this field, when they grow your pea crop, you don't find, I did a study, don't find the rhizobium in those fields. Now, based on that observation, what we thought, if we have to increase the cropping intensity of Assam, now our population has gone up, our cropping intensity is only about 130%, means we grow single crop in a year. So there is a potential of growing 3 crops in a year in Assam. This is what we try to do with integrate nutrient management and also try to compare with inorganic agriculture like NPK, fertilizer. We grow 3 crops from April to July or end of June or July, a Ahu crop, then Sali crop. This is Ahu crop, this is Sali crop. And in December, we sow pea crop and use only organic manure treatment and PK or integrated nutrient management, which include organic manure, rock phosphate, and some biofertilizer, some Azospelum bacillans, Bacillus megatherium, those we isolated, if very effective or effective strain, good strain. And what you see, I am not going to show you the data. This is after 9 crops, after 3 years. So NPK gives you good vegetative growth and yield also not that bad, but integrated nutrient management give you less vegetative growth and more yield, and the soil quality of these is much better. Microbial population is more, earthworm population is more. So there are techniques by which we can increase the cropping intensity without depending on high dose of fertilizers or pesticide. This can be really done and is very relevant for Assam context or even Manipur context. This should not move. Why? My slides are not moving.
Maybe stuck somewhere. Click it again, it will come. Maybe the picture, sometime it happens.
Oh, okay, it has come. Okay.
Yeah.
Now, this is what a general picture of agricultural ecosystem of Northeast and global context, a little bit I want to show. And now I want to move to the few specific bioresources, starting with the organic farming, how these bioresources provide us opportunity of becoming self-reliant, non-dependent on crop job, because a large number of educated youth who went from Northeast or from Assam to rest of the country in search of business, your job opportunity have come back now. So they have to be, and jobs are not there, they have to do something for themselves. So organic farming may be a good venture. So organic farming for scented rice, for export market, Bhut Jolakia. I'll show you a few things of Bhut Jolakia and processing for export, fruit production or processing. These two are good candidate for organic farming. This has very high market value. Few years ago, the Kola Joha or scented Joha rice of Assam was exported to Europe. They organically grown for some technical issues because there was a ban on exporting non-basmati rice, but basmati is scented rice, and non-basmati means Joha rice is also non-basmati, but it's a scented rice, a rice price. So it got stuck. Now I think it is again reopened. Similarly, the black rice of Manipur. This is a little bit of data why we can do organic farming. If you look at the fertilizer use data per hectare, world, India, and Northeast, we use very little. So it is that is why we say it's by default organic farming. Pesticide use in also this 57 is mostly tea state use pesticides. Now, organic food, why people like is because its water content is less, vitamin C percentage, this many more, magnesium, iron, mineral content more, or heavy metal content is less, antioxidant are more than, and organic farming we should respect because it brings back the quality of the system. It brings wild plant species 50% more compared to conventional chemical agriculture, 60% more arthropod, 60% more birds, 100% more butterflies. They are very systematically studied research. So for biofertilizer, your organic farming, what we need is organic inputs, vermicompost, organic manure, and most important probiotics, the biofertilizer and biopesticides. And for some business model, or linkage rather, export to Southeast Asian countries because Act is policy. Europe, we can do organic production of scented rice, Bhut Jolakia, other high value fruits and vegetable. Then for that, there can be a business sector because this, if we put more area under this, we need more organic input. So there can be biofertilizer, biopesticide production unit, vermicompost, vermiwash. We generate huge amount of crop waste in this region, easily available raw material, very easily available. And now this COVID-19 has compelled of home delivery of food. There can be section of producer cluster. There can be grown in cluster. They can deliver home, can I earn more money. One example of Bhut Jolakia I want to put. The Bhut Jolakia, this is Frontal Agritech Private Limited in Jorat. They send 20 to 25 metric tons of dry king chili to 22 countries. They collect from Northeast different parts, and I think this value has even gone up now. And each kilo cost about 2,000 rupees. And Bhut Jolakia is highly productive. Per plant gives you 2 to 3 kilogram, and even 1 kilo if you sell fresh 400 rupees. And of course, if there is problem of, if there is problem of bulk transport of this Bhoojalokia, because it is perishable, it even doesn't last more than 15 days. So in IBSD, one of nasal product chemist, he developed a technique of extracting aroma and capsaicinoid content, the pungency content in a matrix, oil matrix. And what was also seen that this oil, this is the capsaicin standard, and what is value-added products means in the matrix, those flavor and flavoring compound, aroma compound, and pungent compound were extracted. That this is Capsicum sinensis. It has all the ingredient. This is, and this is there can be even instead of whole fruit, so there can be a technology, a product for selling this in a oil matrix base. And there are many other applications of Bhoojalokia. Capsaicin is used in neurological operations and pain management, some gel commercially available. So there can be many other products like that. There can be research and development. And as far as the fruit processing is concerned, Northeast India, all the states except Sikkim produce excess of different kind of fruits. And so there can be a fruit, easily fruit processing can flourish because we produce more than our domestic, our requirement for individual state. And what research we need to do, nutritive value analysis, some of the indigenous fruits, minor fruits, has medicinal value. Those can also be brought to research for product development or for selling purpose. Nutritive value analysis, the factors favoring location-specific attributes, then packaging for long-distance transport, freshness preservation during transit, to do research on those. And what is available for apple or other fruits will not hold good for the fruits we have to do for our fruits ourselves. Another important food research, your Bioresource, traditional fermented food and its potential as micro-enterprise for rural economy. How much time I have? I have to, Dr. Maitri?
Yeah, sir, now it is 11:30. We have 30 minutes more time.
I think I'll be able to finish.
Yes.
So it is okay, everything is visible?
Absolutely, sir.
Okay. So this is a picture of different kind of food that this Northeastern people eat. They ferment everything, right? From fish to cabbage, bamboo, beans, everything. And definitely there is some benefit. And the simple benefit is if you ferment them, then pre-digestion happens and microorganisms are involved. They release a lot of enzyme, maybe growth factors. So digestion problem when it goes to stomach is reduced. So traditionally this has been done means we we have to really do research on it, and a lot of research have also been done. But as far as business exploration is concerned, it's not that great. And I want to give you one example of how fermented food research can earn billion rupees. This is one example of natto. I use this example quite often. This is a fermented soybean. In Manipur, fermented soybean they say as hawajar, and Japan they say is as natto in Japan market, and it has all these mucilage material. These are all bacterial mucilage, and it contains an enzyme nattokinase, which is used for dissolution of blood clots in thrombosis, which it's useful, and this is a market product all over the world sold. Now, we do not know what kind of enzymes or what kind of therapeutics are hidden in the fermented food product of Northeast India. This, however, IBSD did extensive amount of work, good publications. The product, small marketing also we did, but it didn't take off. It was not actually carried forward, but there is a potential on that. This is how it is produced, a very simple procedure. After you boil, mixed with Bacillus subtilis, these are patent deposit. These cultures are patent deposit. Microbial type culture collection in Tech, Chandigarh, we have deposited. These are very good culture. And when you do fermentation, the changes, what I said, a lot of beneficial compounds come. one example is it is free amino acids. In these free amino acids content in the cooked one, only cooked yellow seeds of soybean, and these are different organism fermented soybean, and then see the content of different amino acids. And then the fermented bamboo shoots. Dr. Romi, who has recently joined NIST Zorat, he was working with us as an Inspire faculty. He did tremendous amount of work, had very good molecular ecology. He published very good paper, and you can say fermented bamboo shoot Northeast is pioneering this tremendous amount of work. And a lot of number of good probiotics have been discovered from this fermented food. And in Impal market, they sell fermented soy boom, or not soybean. This is fermented bamboo seeds, all called soy boom. And it's a good market, but still export market is not there. Packaging, processing in a much better hygienic condition can really earn a lot of money, can be a good business venture. Northeast India and rice beer of rural for rural area heritage liquor research. Most of you know it's a social culture to drink, particularly in the indigenous community. Some of the data we generated through survey. And what research we have not done, this large number of herbs they use, what it actually contains, what goes from these herbs to the final liquor, final beer, rice beer, or whatever you say. So we need to understand. Some amount of research has been done, but no, I don't think, still a lot more to do. For example, Jhao Gising, it is Boro community rice beer. They use these different kind of plant leaf, crush them, make into powder, and then mix as a starter cake, where this you have this fermenting fungi or yeast. And this heritage liquor has health benefit, people say. So we did a small research from a large number of sample we collected, because in those communities, not that all people drink. A section of them, they don't drink. We found that. And in a big, even this indigenous community also, everybody doesn't drink. And what we found, we analyzed the gut microbiota. These are bacteria profile of or abundance of bacterial profile. You don't want to go into details of this. Now, this particular lactobacillus species, in drinker abundance is, drinker stool sample abundance is much more. What it is doing in the gut of human, those drinker population, need to study. And also the metabolite profile of Jhao Gisi, Boro community heritage liquor, amino acids and vitamins content, we have discovered those are present, sugars and oligosaccharides, then short chain fatty acids and organic acid, which has health benefit, and some of the pharmaceuticals. And ISST also did a systematic research, and we have developed a rice wine, red rice wine. We are hoping that it will fetch premier prize with some company we have been negotiating. And we have also got a project for under PACE scheme of BIRAC for pilot scale production of this. And this, you all know that some government has opened up selling of heritage liquor openly to promote business on it. And indigenous people should get benefit, and we can research, if you can add value through research on it, it will still be beneficial or earn more money. Agarwood bioresource, this is one very interesting bioresource of Northeast India, entire Northeast India. Agartala, it come from Agartala city. Perhaps it had all these agar plantations. There are several species of agar, Equularia malacensis, and these values, what it indicate actually, global trade value. So these species is traded most in the world. There are several problems and limitations of in this, and it's a monopoly one-man business now. We all know Ajmal Seth has a huge business on this. I want to, this slides is a little bit busy slides, but bear with me, I'll explain this. Those who are not aware about this agar plantation stand, when you cut this cross section, you find this hollow thing. Actually, these are all infected by fungus, and it is believed that a particular insect species called Jugera make a tunnel, and then some fungus infect. There is a paper, I think Dr. Unni is also author of this paper from Neist Jorat. They found about 24% of plant association plant in a stand infected or infested by this particular insect, this borer, and then fungal growth occurs, and the plant try to resist those infestation and infection by producing sesquiterpene. It's a defense compound. Sesquiterpene resists pathogen attack, and the plants survive in that fight. Plants survive several years, and then we harvest them. And now, right at this moment, there is no standard procedure of knowing which plant will yield more sesquiterpene, or chips they call, wheat infection. There can be research to develop technology to standardize or develop some method of knowing before harvest, before cutting the tree. And in general, as per this, if there is 23% infestation, then there should be in a stand, 24% plants should be, as per another data, that infection is less than 10% and uncertain. In some stand, there may not be infection. There are some conflicting data, of course, but overall, in a stand, you do not get 100% infection, that for sure. That's a major problem requiring scientific attention. No scientific technique again for detecting the level of infection. And in standard grading, there is no proper grading because there are several grades. The highest grade fetch more price. Now, one thing, a thought came, a postdoctoral fellow started working with us. I thought maybe plant-to-plant variation, why some plant escape this attack. Maybe this is, these seeds are heterogeneous. Maybe, I thought, I'm not a botanist, but I thought maybe if it is a cross-pollinated crop, then there will be a lot of seed diversity. And in fact, I came up with a report of Institute of Forest Genetics and Tree Breeding, Banbiggan, they come out a publication. So they said this is a highly cross-pollinated species, though there is something, I think this has not been looked into very thoroughly. This is a research issue we can look into. And this is a plant, like its chips are used for sesquiterpene for the fragrance. Then its timber is also used, and it has medicinal property. Its leaf has like your agar leaf tea. You can buy it in market also. Agar leaf tea is very good for health. So even jewelry is made from the wood. And so these are some business, both export, reported import and export volumes. Details is not important. Now, this one, okay. Now, you know, I want to, just for, this is a, some antiques are made for your agarwood tree. And this, please read this. During the 6th century, this is in Japan, they used to, like second oldest book of classical Japanese history, they used to write on that in log piece of thin pieces of this wood. They used to write recorded history. And our Sri Sankardev Sasipat, he used to write in some also 15th, 16th century. So that's something very interesting. And now you all know that this is a highly, this is said to be a endangered plant. In forest, you do not find this Equularia species because it has been ruthlessly harvested. And the Assam government particularly has come up with big mega project for plantation of these everywhere. And even wasteland, this can be, even in tea tea growing place, tea estate, this has been used. So there's a good news that extensive planting of these agar has started. So now there can be research for finding out, or there is some strains already available of poor fungal strain. In ISST also, we isolated several fungal isolates and one fungal isolates on the tissue culture material of, means in Kellas, when you put this fungus, one particular fungus, Fusarium species, produce sesquiterpene, which is which can be resembled with some sesquiterpene. Sesquiterpene is a diverse group, like its chemical structure is quite different. So we have a large diversity of sesquiterpene. So we found with some sesquiterpene of nature, this particular sesquiterpene produced by that fungus in Kellas, it's comparable. And then in artificial artificial inoculation, small amount of infection happens. Now, what is happening? This person, I have never met him, Zahirul Islam. He has a business group, MZI, some of you may know. Like what he says, he has named this Sasi Vekur. They say fungus, which he says can infect 100%. Now he sell these Sasi plant, agar plant seedling, and then he will also carry out infection. He'll also buy the plant. I do not know the real science behind. Everything was okay, but some word he used about organic, invented new technology and organic, that I of course do not know. But still, maybe some of the, there is a lot of scope for research on this. And then another plant is of the BTC area. During Boro movement, the large scale removal of this khair plantation in your Bhutan foothills, foothills or in BTC areas, there used to be extensive, and this plant has khair that we use for pan, and it also used for making, it has a lot of medicinal property, and also used for natural dyeing purpose. There can be rejuvenation, there can be research for on this to again rejuvenate this plant production and utilization. Assam tea estate generate huge amount of waste. In the made tea, for every 100 kg made tea, you get 40 kg at waste. And in ISST, we developed a technique of production of activated charcoal by treating them with banana pseudostem aqueous solution, which pH goes to 11 to 12. And this can be a very good filtration material. We are still working on its pore size distribution. It's not yet normal distribution. In a larger pore size, it has large quantity of material. We want a uniform distribution. In smaller pore size, then it will be a better material, filtration material. Small filter can be used. Activated charcoal, right at this moment, about 80% of activated charcoal of the country is imported from China. So there is an opportunity of producing activated charcoal. Now, edible insects of Northeastern hill states. If some of you are listening from Northeastern hill states, in the world, about 1,700 species consumed by 3,000 ethnic groups. And these protein per 100 gram of insect contain protein, which is equivalent to either pork, chicken, or beef, almost equivalent. So there can be, and even Manipur and other hilly states, you regularly see insects sold in the market. This is Balostoma, giant water bug. One piece cost 15 rupees. In 2005, when I went to Manipur, the price was 3 rupees. When I came in 2014, the price went to 15 rupees. So if you can develop captive breeding or cultivation production, there's good business there. And Southeast Asian countries, edible insect market is very attractive to look at. Now, this is a world edible insect business in particularly Southeast Asian countries. In 2023, it is likely to expand from 2018 to here, and this is getting a problem. Okay. And this production of insect, edible insect compared to chicken or pig is very remunerative because it requires for per kg production, you require less amount of land, less amount of feed, less amount of water. Producing a beef per 1 kilo require all this input large quantity. So, and there can be new opportunities for entrepreneurship, for human resource development. Technique has to be developed for production, multiplication, small indoor breeding of or production of this insect resource. Medicinal plant resource, I think yesterday Dr. Vikas said a lot of things, maybe very briefly. And this will be maybe the last slides, or a few more slides left. So, like current approach of drug discovery from herbal medicine, 80% of antimicrobial, cardiovascular, immunosuppressive, anti-cancer drugs are plant origin. And of these 80%, 50% means are direct, like first time isolated from the plant and then modified and repurposed or used for diverse use. This is very interesting. Global spending on prescription drug in 2006, this many million, and maximum amount of drug is consumed in USA. And it takes 10 to 15 years for a new drug to become marketable. And this is very, very interesting. Why I'm trying to bring some interesting context of medicinal plant research in Northeast India. In 1996, spending $25 billion, 50 new drugs could reach market. And after years, in 2005, spending $50 billion, only 22 new drugs have been approved by, means in 10 years, spend more money, double the amount of money, and you have got less the amount of drugs available. So drug making is becoming so expensive. So that is why there are a lot of issues coming, researchable issues, how to reduce this cost. One way is recent discovery in that reduction in burden on animal experiment, large numbers of in vitro, in a huge number of in vitro assays are developed now. You can reduce cost there. Then single molecule versus mixer in food extract. Now phytopharmaceutical, your herbal medicines even prepared properly and authenticated can have good market. If the scenario of the pharmaceuticals, like single molecule drug is that, so there is opportunity, and phytopharmaceutical research in India is going on in full swing, and ISST is also part of it. And then integration of herbal medicine with modern approach, integrated approach, complementary and supplementary medicine. Now some Northeast hill places, they even medicinal herbs, they make tablets. One of the survey we did in remote areas, they do their treatment with this kind of medicines. We have been authenticating some of this product. This is okay. Only point I want to bring to young researcher is that China is the other side of Himalaya. We are in this side of Himalaya. And the Chinese, if you do the database search, the traditional Indian medicine and traditional Chinese medicine, now paper publication, citation, US patent, like in everything, they are much, much ahead. And why they are ahead, I tried to think, see the insight from traditional Chinese medicine, what kind of quality control they do. And this is one store, my hometown, I belong to TU. He's not bad. He's also doing very good business. So if you want to have capture Indian market, world market, our quality also. By the way, ISST has a quality control and quality assurance laboratory to determine the quality of herbal medicine, phytopharmaceutical for the stakeholder of Northeast India. Now, this is a work last 4 years we did. This is a plant called Premna herbaceae. Got it from the Boro community. And we have come up with two molecules. One is verbascoside and isoverbascoside. It has both anti-diabetic and also anti-lipidemic, means it can also reduce your cholesterol level. And through systematic research, we have shown that it can reduce blood glucose, and we are now doing a clinical trial. There is an international patent on this, 2 national patent. So this was a successful research that DBT funded us a good amount of money. Then in Northeast, we have about 15 commercially traded medicinal plants. If you need, some of you need, I can send this list. I will not deal on that. So these are most extensively traded from Northeast India. About 4 states, company located in 4 states of India, get it from Northeast India. Then Seri Bioresource, very quickly, these are 4, and in Northeast, Muga and Eri are most common. We do not, mulberry doesn't do well here. And one major problem we are addressing and is that if you feed these in 2 plants, Mazankari and Muga, the coloration, same organism, their coloration change. And also we saw 2 distinct morph. One is green, one is little bit bluish. The green one produce your very golden color silk, and this produce. We are trying to understand why this happens. And this color change happen immediately after the trade material comes out. It doesn't become golden yellow. When it comes in contact with air, that is, at least when you keep them in a vacuum, the color doesn't change. But if you keep in air, then the color changes. This is one research, and you can find out there can be many other research done on sericulture resource, Muga and Eri. Now we have so much of resource in the region, and this is the real business story is this. Household scale earning, small earning. This is Meghalaya. When you go to Shillong, you can buy pineapple like this, few bhut jolakia, few kilo bhut jolakia, Eri pupa selling. Some mushroom production happens. Now this has to be carried out in entrepreneurial, little bit large scale entrepreneurship. Young people has to come out. And this is the current, like if you talk about food processing industry in Northeast, compared to total India, investment is very less. Input values, like everything is very less. Per unit cost, return is very less. Manpower and engagement is very high. And this is, see, employment per crore fixed capital. Like we use more than double the amount of manpower. So maybe people say our workers are kanya, so maybe they're not productive. So there are many issues. And other thing, I think with this bioresource, there can be, because in rural area, our ladies or every family, women are very hardworking and enterprising. So we can form clusters. We can induce them to produce mushroom, to produce eri, to prepare vermicompost. In fact, we did we adopted 2 villages and had very good experience of increasing, providing the input, the seeds of eri, providing them spawn of your mushroom cultivation, and then they did very good. In 3 years' time, their economy of each one of them, each family, improved substantially. We helped them sell their material one time, they get better price. Now, business in mushroom research and business. If you look at, if somebody asks me what is the research gap, we have to do research for selection of strain of mushrooms for cultivation during June, July, August, September. During this rainy season and high temperature, like your oyster mushrooms and all those mushrooms that you grow, even button mushrooms doesn't perform. As such, button mushroom, we have to do a lot of research. It is, other day when I made a presentation, people asked that we should go for button mushroom, it's more expensive. So we have to do research. And there's a lot of opportunity. Even India, there is a lot of opportunity for doing research on mushroom. If you look at Asia Pacific region, this many 10 million metric tons of mushroom, this is the volume of mushroom consumed. In India, only 0.313 million metric ton, much less. And among different states, Punjab produce maximum amount of mushroom. Nagaland in Northeast, they are doing good. They produce more mushroom. Assam is poor. So there is an opportunity of mushroom research and business. And also we must think of research on diversification of value chain, adding value, rather than selling rice alone. Like rice production, this is a good statistics. Per hectare, rice production cost 18,000 rupees and sell 15,000 rupees, and you get only 18,000 rupees selling the rice of 1 hectare of land. But if we use rice bran for rice or rice bran oil production, husk for energy source, then the straw that is discarded for mushroom production, that it per hectare income from rice can go up. These are the things we must think of doing. So mushroom component, that is, we have to do research on selecting mushroom, except oyster and this oyster mushroom and white milky mushroom. Rest are not doing very good. So we have to do research on that. So these ladies whom we support, a success story, they grow, some of them really earn good amount of money. I think these are okay. We have our PhD students started, because for those students who have been watching this, our PhD student, after their thesis submission, they started producing a candy, nutraceutical candy from Garcinia morella, which has anti-diabetic effect, anti-lipidemic effect. So some of the product of ISST, we're also doing work of fermenting the chips efficiently, then rice wine and the Garcinia. Then we have a biofungicides. It's a license to a factory. So these are the, now on bioresource, these are the things that we can, like bioresource to bioeconomy of the region, agarroot, standardized fermentation and oil recovery, artificial inoculation, tree biology, research you can do, non-mulberry silk, eri and muga, microbial mediated, this is of course I didn't cover it, medicinal herbs, Ayurvedic and phytopharmaceutical root, fermented and other indigenous food and health research. I think I've come to an end. Thank you very much.
Yes, sir. Thank you very much. I think this is a very informative session for all the participants. Our region is so much rich in bioresources now. It is upon us how we will utilize and how we will do systematic research to help our young generation. Thank you very much. Now this session is for discussion.
Yes, ma'am.
Sir,
yes, sir. So it was indeed a great session. Means it was very generic, and your slides will, I hope it will definitely help the young generation like me to think on diverse area of research, and obviously on various areas of how to make business from the indigenous products. So, sir, we are having few questions.
Sure.
First question is by Sankaram Palli. His question was that probiotics of human systems are preventive or cures for diseases, and for soils it is to compensate for deficiencies or supplementary soil nourishment and enhance soil fertility.
I think all probiotics, they are all your preventive. They are there with us to protect us from undesirable effects, because I think they are a great defense, a very strong army to protect us from things. But once you have disease, and then if you take probiotic, I don't think it can cure. But what they say that why it is probiotic is because of that very name probiotic. Suppose you have taken a lot of antibiotics, and your disease to control the disease, you have taken antibiotic, your organism got killed, harmful organisms, but this antibiotic will not distinguish between your enemy microorganism and beneficial microorganism. It get killed, and that's why most of the time each one of us has that experience. After taking antibiotic, we get diarrhea. It's because our protection has gone. So all those beneficial microorganism has gone. That's why nowadays doctors prescribe probiotics after antibiotic. After a few days you start, so that your gut microbiota get rebuilt and continue to act as a vessel for your health. Okay. And the second one, you have said soil health. Soil health.
Compensate for deficiencies, sir.
Yeah. Now, I think what is happening, yesterday, I think Saurabh did a lot of philosophy. I also do a lot of philosophy. Actually, if you look at the forest and that forest ecosystem, whatever has been growing, it is growing naturally. Suppose a place which is barren, nothing is there, and now gradually you start building a forest. Now, it automatically come. You find first year 4 or 5 plant species, next year 6 or 7 plant species. After 10 years, you find it is stabilized. It has a fixed number of plant species. Now, who has chosen? It's not human being that has given seeds of no. So nature has chosen itself. Nature has chosen. It's also not only nature chosen. This plant, they see that each plant, we need 16. All plant, all animal, human being, we need basic 16 essential nutrient elements. What nutrient elements are there in the plant, that is there in the animal, that is other animal, and that is present in the human animal. Now, a plant, but the proportion of these nutrient elements are different in every individual species of either microorganism, either higher plants, either lower plants, in other animals. Now, those plants which grow, specifically adapt and develop the ecosystem, balanced ecosystem, they realize, they sense that for whatever amount, proportionate quantity, the nutrient in proportionate quantity I require, it is there. So it just take foothold on that. And those which seed may fall, it may germinate, but it sense that it is not there. Now then, how intelligent these human beings are. We claim ourselves very intelligent, done a lot of research. How intelligent we are to understand this requirement, and how intelligent we are to devise a production system to put the site-specific plant to extract nutrient in that balanced matter. I don't think we have that. And that is the root cause of this intervention of different kind of plant. The same thing goes with food we take, young generation take. I think a lot of food we take is because of TV. It may not be doing our balanced nourishment. We must know all this, right? So then, one thing is for sure, that you have to apply as much as possible compost material, because compost will have a diverse plant material. You derive them from diverse, so you are likely to be enriching soil with heterogeneous nutrient in right proportion. Okay, so if we do systematic research and study and thoughtfulness, definitely we can restore soil health, and it has been done. And organic farming is one way, at least it doesn't kill the organism like the chemical fertilizer, pesticides.
Okay, sir. So
have I given the answer? I don't know. Like it's.
So I hope it is clear to our participant. So another question by Briganga Vadwaz. He's asking that, sir, can the nutritive value of mushroom be improved by supplementing the substrate?
I would say I don't have any research data evidence. There may be, definitely, if you Google, you'll find, definitely it can be done. Recently, one Innotech company, Guwahati, he is a All India retired person. They have developed a technique of treating mushroom with small dose of UV light, and they enrich them with vitamin D. So there are even technique of enriching with different rich nutrient, growth factor. So definitely it can be done. We need to do research.
Yes, sir.
I'm sure.
So another question by Dr. Madhulika Datta. She's saying about the deforestation. For coal mining, we need to go for deforestation,
Yeah.
and due to which there are removal of soil nutrient. So she's asking that is any fast and effective remediation steps can be taken to preserve the forest and obviously soil quality in those areas.
Yeah, I think Jorat Nest has done a lot of work on it, and also the moist and deciduous forest. One students worked with me on that. The question you have asked, I can
Yes.
explain. I can give you a lot of data. Even two students did PhD. In fact,
Okay.
when you do Margarita in those area where
Yes, sir.
you do blasting, because that's an open cast mine,
Yeah.
because you have that undesirable that is undesirable for the miner, for the engineer. The coal is hidden there, but above 5, 6, 10 feet of material are useless material for them. They blast it, destroy all the forest, and then bring the coal. Some coal contain about 4% of sulfur, and in those area now, this coal residue will add lot of sulfur to these overburden dumps. What they remove from the top, they dump them. It is called as overburden dump. And these overburden dumps are deficient in nutrient. Overburden dumps are highly acidic because sulfur get oxidized, produce sulfuric acid and become highly acidic. And for 3-4 years, you get no growth there. Now, we developed a successful technique of using rhizospheric bacterial inocula and mycorrhizal inocula. And first, from second year itself, if you inoculate Crotalaria zansia plant, you find in those area in abundance. The seeds you inoculate, mix, and then spread on the surface of overburden dump, you get very good growth. So definitely the overburden dam can be revegetated, and there are technology available. And I think there are some technology adapted also. Even Nest Jorat has some technology.
Okay, sir. Sir, let me take the last question, sir. This question is again by Sankaram Pari. He's asking that there are several traditional medicines, but they cannot be involved in systematic medical research since they do not have qualification. So how the research activities or institute or how institute can help uh, or support them to extend this situation, or to what extent could this situation be concealed with as of now?
No, I have little. I don't think I have understood the question very well. But
So, yeah.
If no, what he said is there are some traditional knowledge-based medicinal plant, which, if I rephrase if I am right, so which are barred from doing research, or which has not been accepted because we do not have proper scientific data. Is
Yeah.
it? Okay. Now, there are there are many medicinal plants which the indigenous people say has value. They get good benefit, but to bring it for large population use or to do business with it means we have to how to convert it to evidence based.
Yeah.
But that has to be made, means you have to authenticate the claim of traditional healers have to be authenticated. For example, I showed one example. Premna herbaceae is a plant used by Moro community. They use this plant and they say that we remain it makes you remain less fatty. You don't gain body weight. Even when they make pork, they put these herbs leaves. So many of their cuisine they prepare by putting this leaf. Now this is a belief system kind of. They never have any scientific data. Now doing systematic research, what we have seen is it can reduce your lipid accumulation, cholesterol. It can reduce blood sugar. We have seen that there are two compounds. One is called verbascoside, one is isoverbascoside. There are many other compound which we are still studying. So then the systematic research shows that the claim they make has now we have created evidence for a claim they had, right? So the plants, this particular gentleman who has asked me this question, those plants which are used by traditional medicine to have a market value, we have to do research to develop evidence, scientific evidence, through systematic research in laboratory. So we have to have a natural product chemistry, phytopharmaceutical laboratory, or maybe a biochemistry laboratory. Collaborate people who have knowledge of natural product chemistry, organic chemistry, biochemistry. You have to collaborate with people who can do animal experiment. We have to collaborate people who have cell culture knowledge and facility. Hope I have given the answer.
Yes, sir. Yes, sir. Thank you very much, sir. It was indeed a brief idea of how we can work on many various sectors and commercialize all this. It was indeed a very great session, sir. Thank you, sir. Moitri ma'am would conclude.
Yeah, so thank you very much. And if the participants have more questions to ask, then we'll provide sir's email ID so that they can interact with sir.
Maybe better because you are conducting this. My suggestion is you take the question, and whenever I
sure.
This will be better. Okay.
Okay, no problem.
Please,
no problem.
Please do that.
Yes,
And
I'll provide my email ID, then send to me so that I can send it to sir.
Thank you very much. Thank you all. All the participants. It was great to talk to you. All of your face, I didn't see each one of your face, but it was great. Thank you very much.
Thank you. Then I think we can start the second. Okay, now let us start the second session of the final day. Our speaker will be Dr. B.G. Unni, and his topic will be Science is for the Society and for our basic needs. Let me introduce Dr. B.G. Unni, sir. Sir is the former chief scientist and area coordinator and Dud and Fulbright fellow, retired from CSIR service on 31st January 2015 after 38 years of research career at CSIR Northeast Institute of Science and Technology, Jorhat, Assam. Appointed at Assam Downtown University as Director Research in March 2015 and continued up to June 2019 and redesignated as Advisor Research since August 2019. Back in Kerala, Dr. Unni is appointed as Director Academic and Research at GEMS College of Arts and Science, affiliated to University of Calicut since August 2019. Both the positions are on honorary basis to strengthen the institution in research areas. He did his BSc Biology from Ewing Christian College, Allahabad University, MSc in Biochemistry, 1974 to 1976, and PhD in Biochemistry from Allahabad University in, it is between 1976 and 80, and PDF in Molecular Biology from Texas A&M University, USA. Dr. Unni is specialized in biochemistry, molecular biology, and biotechnology, and well established in his area of research and completed more than 38 years of research in both basic and applied field of research. Dr. Unni got more than 115 research papers, 180 abstracts, 35 paper in proceedings, 4 patents, 1 technology, 18 chapters in books, edited 3 books, and 26 students received PhD degree under his guidance and supervision. Dr. Unni had completed more than 20 projects sponsored by Commonwealth Science Council, London, Ministry of Non-Conventional Energy Sources, Department of Non-Conventional Energy Sources, Government of India, Northeastern Council, Government of India, Department of Science and Technology, Department of Biotechnology, Central Silk Board, GB Pond Institute of Himalayan Environment and Development, CSIR and DRDO, Ministry of Defense, Government of India during his scientific tenure at CSIR NIST. Dr. Unni received Fulbright Travel Award, Dr. B.M. Das Memorial Science Award, Hebrew University Award, Dart Fellowship Germany, Wellmark International Scholarship and Technology Award in Life Sciences by CSIR Government of India. Best Fulbright Alumni Chapter Leader South Asia selected by the United States Education Foundation in India. New Delhi. Nominated to represent India at the International Fulbright Scholars Meet at Marrakech, Morocco, nominated by United States Education Foundation in India, New Delhi. Dr. Unni is the editorial board of more than 8 index journals in the country. Dr. Unni was nominated to various state and central committees such as High Power Committee for Development of Sericulture Activities, Mugga, Edi, Teshar and Malbari in Assam, nominated by Government of Assam. Expert in the area of non-Mulberry Sericulture, Ministry of Textiles, Advisory Board, Postgraduate Biotechnology Program, Academic Council, Assam Agriculture University Research Council, Central Silk Board, Ministry of Textile, DBT's nominee for Biosafety Committee, Vice President SBC Indian Institute of Science Bangalore, Vice President Indian Academy of Neurosciences, member Fulbright Academy of Science and Technology USA, Board of Studies Botany, Nagaland University and Biotechnology, Sugar University, Madhya Pradesh, Fellow Indian Academy of Neurosciences and Indian Society of Agricultural Biochemists, Fellow Royal Entomological Society, London, UK, and Scientific Advisor, International Foundation of Science, Sweden, member Board of Studies, Raiganj University, member Research Review Committee, Tea Board of India, member Advisory Committee, Cancer Research Advisory Board, Northeast Cancer Hospital and Research Institute, President, Tea and Improvement Consortium Limited, Toklai, Assam. Dr. Unni visited USA, Germany, Israel, Jordan, France, Morocco, UK, Thailand, Jordan, Singapore, and China under various exchange programs. Now I request sir to start his lecture.
Thank you. I think it's audible.
Yes, sir.
Is it audible?
Yes, sir. Yes, sir.
Okay. Okay, now you must have seen the talks for the last 4 to 5 days on different aspects. Now the theme is what the fund the university get or the research institution gets, how it is going to be useful to the society. So my talk is something very different. What I said, science is for the society and for our basic needs. This is the basic things. This is the principle what I'm keeping it now to talk. So far, as on today, if you feel this is very important now. Once upon a time, when you start about long back, when there was hardly, when I started my research career in 1976 from my PhD, that means almost about 45 to 46 years. There I found, I used to listen only CSIR, and then because I got the fellowship on the national level, CSIR, that time there was only one scholarship that time CSIR used to give, then UGC for the toppers and from the DST. The DDBT started existing from 1980. And that time, most of the time, people used to talk about the funded project from DST on basic studies. Then the DBT came. I don't know how many of you know about the first secretary of DBT, that is Dr. S. Ramachandran. I had an opportunity to host his lecture in 1980 when he visited RRL, that time it was called RRL, as an advisor to DBT. There was no DBT during that time. And that time, the first time I heard a very interesting talk on biotechnology. Later on, he became the first secretary of DBT. I think nowadays people have forgotten his name, but he is still there. And he is the brainchild what you have seen in the DBT. There are a number of secretaries came, but he has taken a lot of steps. And even from the, you can talk about the silkworm, the Siri biotechnology, it came in 1990 onward. I will talk all these sort of things later on. But what I'm going to talk today what is my contribution as far as in research with respect to the society. Then my colleagues' contribution in funded project, and then ultimately it went to the society. Then my parent laboratory, what they did for the society from the funded projects, how much technology they generated. Even many of them may not be knowing the contribution of CSIR NIST. As on today, it is not, it was RRL. There are large number of technologies from dustless chalk to the vertical shaft, big cement plant. It has gone up to the more than 100 institutions, 100 entrepreneurs around the country and outside the country. So these three aspects, what I'm good, my own contribution to the society, my colleagues' contribution, and then to my parental institution. So I will speak more on the how much the impact the research has gone to the society. That is what I'm going to focus more on that. Now you can see the science generates solution for everybody life and help us to answer the great mysteries of the university. That is what's the ultimate thing what we are getting now. In other words, science is one of the most important channels of knowledge. As on today on the COVID, that what is happening, everybody is going for the vaccine. That means immediately you wanted to have a product. That's the reason we have selected this topic. How much the research is going to the society. It has a specific role as well as a variety of function for the benefit of our society. That is the ultimate aim. Creating new knowledge, improving education, and increasing our quality of life. Now, as on today, it is very important. Science has to improve the quality of our life. Science must respond to societal needs and global challenges. Public understanding and engagement with science, participation including through popularization of science, essential to equip citizens to make informed. That is what the way I'm going to do. That how much the science, which has funded to me, to my colleagues, to my parental institution, has gone to the society. Governments need to take decisions based on the quality scientific information on issues such as health, agriculture. National government need to understand the science behind major global challenges such as climate change. People are talking everywhere. Ocean health, biodiversity, where Dr. Talukdar has very nicely, very elaborately talked about his contribution with respect to the biodiversity, utilizing the resources, how much research, how much his effort, how much the contribution has gone to the society, and how much is left behind, where the younger generation can take up. Scientists must understand the problem, policymakers face to face, and endeavor to make the results of their research relevant and comprehensible to the society. There is a general feeling that it was there in the long back. Even now, sometimes people have talked about academic researchers are not much useful and reaching to society. This may not be true. As on today, when I started my research career, in fact, in 1979, back in my institute, hardly there were any molecular contribution or molecular research laboratories in the Northeast. Now, if you see after 30 years, there are so many best institutions in the country. A lot of molecular contributions is coming from Northeastern part. So you can see the changes. Even from the academic institution, there are quite a number of 2 or 3 central universities are there in Assam now, doing a great as far as contributions in the molecular biology, the science is concerned. Most of the time publication are made, get academic promotion and for personal gain. Is there any ways and means to make academic research useful to the society? Now it is there. They are making it. If it is not there, we have to do that. By collecting local issues, resources, that is what Dr. Talukdar stressed upon. Even my parental laboratory, RRL, has done a lot and still doing on that. Projects are cheaper cost. That is the most important. Therefore, yesterday when Surubananda was talking about the conversion of energy to the ocean, how it is cheaper, economically feasible to a common man. I can tell you some of the work what I did in silviculture, the silkworm, the muga, that goes to my heart. How much pain I have to take, almost 20 years to come out a problem.
Your voice is not audible, sir.
It's her voice. Manas?
Maybe his network may be down.
Yeah.
Yeah, his network is down. I think he left. Dear participants, please be here for 5 minutes. I think Unisar's network has been down. I have called him now, so he's just working on it. So please unmute your mic, sir. I can see you. Sir, your mic is muted.
Is it okay now?
Yes, sir. Yes, sir. Yes, sir.
Okay.
Yes, sir.
Okay. Now it's okay, audible.
Yes, it is audible, and your slides are also visible, sir.
Okay. Now one should aim, sorry for that. I don't know how it happened. So one should aim for before planning for a research project. This is very important. One research goals must be matched to an area of social importance, maybe health. So all these areas, what I have contribution, my colleagues' contribution, that what I'm going to talk now. Now, my talk is based on myself, my colleagues, and my scientists from my department, and my parent laboratory. Government-funded projects and the outcome utilized for the protection of environment, making unfertilized, little bit the title given by Dr. N.C. Talukdar. I'm going to talk on that. And from that, what are the areas what I covered, and I could make up the projects on that. These are the one of the topic what I'm going to speak. Then government-funded project, research outcome, utilized for the benefit of the people in health sector related to the medical issues. Government-funded projects and the outcome utilized for the need of uplifting the daily bread and butter. I will be speaking on sericulture, where I contributed mainly on Muga silkworm. Government-funded projects and the outcome utilized for an ultimate substitute of energy. Again, this is the research I started in Carrier in 1975 later on, and how much we utilize and give into the society. Government funded projects and the outcome to develop simple technologies in all areas for the benefit of the young entrepreneurs, ultimately useful to the, this is what very recently the Prime Minister of India said, the vocal for local. So for my laboratory's contribution for the last 60 to 70 years, given to the society, entrepreneurs have taken up and benefited by the people. That is what the theme, what I'm going to speak more on the society page. First, the government funded projects and the outcome utilized for the protection of environment. These projects were funded to CSIR needs, Jorhat by Oil India Limited, ONGC, and other government funding agencies. You can see here an approach for the, I will speak this all about 40 to 45 years work within 30 to 40 minutes. So I'm not going to give more details on that. You can see here on this part in the slide, the black color. This is the area which was totally converted to the bioremediation and biophytoremediation. You'll surprise how this slide, the place has transferred to this. You can see that I put an area, which is the main contribution of my colleague, Dr. Nilima Saike, who is the first lady, got the environmental protection in the award at the national level. You can see the slide here, how it is converted. This is the group of microorganisms, filling the area with mud and covered with the microorganism generated, even developed and got it by us, purified by us, spraying on the area, and then the wild plants are allowed to cultivate. And you can see this area which convert, this is what the unfertilized area, which near to the oil drilling site where farmers are deserted, their fertilized land, they are getting money, but how they can make it to more beautiful fertilized area, the biophytoremediation. That's real contribution. That is what one should, so the pollution is controlled, environment is free from pollutant, and the land is fertile. You can see it here, how this area on this side, these all are nearby the Assam, the northeastern part of India, where it's converted with a contribution which is really, really useful and gone to the society where the fund is given by government agency. So this is what, this is not a 3 years or 4 years work, but ultimately it was useful to the society, to the people. That is what the message I wanted to give in every study. You should have some target in front of you, what you will give when the project is over to the society. Now, the government funded projects and the research outcome utilized for the benefit of the people in health sector. Now, you have seen the earlier one. When I was associated partially or nearby to this work, I found the environment has very near to the area people are staying has got some impact. So this was a network project funded by CSIR. Once upon a time, the CSIR used to have a task force project with a limited people, laboratory oriented. But later on, this shifted to a network project where 30 to 40 laboratories together, even each group in cluster wide. So every laboratories are associated with the others. Somebody is missing with an infrastructure equipment, you can share with other laboratory. So in this network, I selected the people, the villagers, the very poor people staying very near to the coal mine area, paper mill site. Then the other areas where oil drilling sites, how much it affects the people. So you can see the face of a coal mine worker, which is very near to the open coal mine. What has happened to these people? What about their health condition? So it was a network funded project. My work, you can see the people working continuously, even 8 hours. They do not have that much shift. So my idea is that how much environment pollution affecting to their health. So you can see it here. The slide says blocked. It has created some problem here. I'm going fed up with this. Some of the problem came out here. Okay. Now you can see what we did. We took the environment analysis, total. What is happening with the pupils staying nearby, the survey, environment, the vegetable they consume, they cultivate from the area, then the environment analysis, water they take, then the health related survey work. You can see the smoking. This is also, we took it as a part of the project, whether the smoking effect at a different sector. You can see the habit of tobacco, what it contains, the cigarette, they use. These all sort of things are consumed by the irrespective of the cadre of the people. Then we went for a survey with every villages very near to the area, coal mine site, then the oil drilling site and paper mill. We took the data. This is the systematic analysis. Afterwards, we took the survey based on the survey data. We accumulated the data. What are the things happening in that particular area? Chronic bronchitis, chronic cough, breathing difficulties, chest pain, blood in sputum. So this is generally affecting to the persons working associated with this area, but they do not know. Now, chronic obstructive, chronic cough symptom, breathing difficulties. This is the respiratory symptom observed in non-coal mine site because this is as a control. We took the health cap. Now, this is a part of a project went for 5 years where a team of doctors goes, stay there for 2 to 3 days in camp. They take the pupils around nearby the villages. We go for a short treatment. We go for a long treatment. The medicines were given free of cost. So you can imagine a project funded by government, how much it is solving the problem, how much we are giving the doctors, the team of doctors are giving a free treatment to them. So this is what the ultimate aim of a project one has to take. Now, we have to go with the air analysis. What is happening in the air where the people are staying? They have no idea. Now, then they have taken the chest. Now, those who are working in the coal mine, the environment, they inhale it, irrespective of the age group. And we also found a considerable low value of the chest, the lungs capacity. It should be above 80. We found it's very low level. They have no idea about that. We could analyze and group into 2 sections, making a control, the coal mine area and the non-coal mine area. What we found, the environment has got a very significant effect as far as the coal mine and the oil drilling, other workers staying nearby as concerned. Overall health condition is very poor. You can see that the analysis, what we have taken, published in a paper, but at the same time, we also got a significant information that the COPD, the chronic obstructive pulmonary diseases are leading to the effect to the lungs, which is caused by the environmental factors, not due to the some sort of, inborn errors. Sometimes people used to say that inborn errors of metabolism, but it is not. Environmental factors can also cause disease. Now, when I said in the beginning, you should have a good papers in a standard journal published. Whenever you have a good work done for the society, this information we will give it to the coal mine people. This information we are given to the oil India. This information is given to the Gaon Panchayat. So what will happen? They will have a control mechanism in future, and the people staying nearby are also awareness what problem they are facing it. So after all, as an ultimate effect of this project is the information given to the society. Alarming situation is like that, you have to have a control. Now, the government funded project and outcome utilized for the need of uplifting the daily bread. And this was the project, first time the Northeast received in 1990, when the DBT started Siri Biotechnology. There were 29 proposals that time considered, and the review meeting was at Guwahati. I'm talking about 1993. They recommended only 5 projects. 3 projects went to Northeastern India. That was in the Jorhat side. And this was one of the area what I concentrated was on neuroendocrine regulation of silk protein. What will happen? Any environmental effect on the silkworm, because this silkworm is reared outside. So anything happened with the environment. Human being, yes, there is a problem. What happened to the Muga silkworm? I found there was a considerable damage in the silk production. Ultimately, it affects the daily bread and butter of so we could make out a lot of studies and analysis. We also could collect large number of Muga silkworm just to see to the molecular biological studies to find out the best marker, the best silkworm, Muga, which can produce the highest silk. So this is a part of a basic studies where the PhD work will go. But my target was what sort of information you are going to the silkworm farmers where they can increase your daily bread and butter. Now, this was an information which came in 2018 when the Vice President Naidu visited at NIRIS, one of the laboratories that calls for innovation. That means institutions interesting with the research scholar and faculty members, he addressed that we should encourage for the innovations. That means that is what happening now. You have a research, you have a knowledge generated, then you have a technology. That means ultimately you go for an innovation, and then the innovation which must be popularized in the society. Now, during that silkworm war, what I found just before the silk protein production, you can see it here just one day before. This is the healthy one. This is the one just one day before it become black in color. This is a disease which was very common during that time. We call it flagell. I took about almost 15 to 16 years to solve this problem. How to control this disease? You must be knowing locally it's called Helica. In scientifically it is called Terminalia cebula. We took this fruit, dry fruit. It was a project given by the Ministry of Environment and Forest. We took large number of medicinal plants, find out the best extract. In simple way, I'm telling you, about more than 100 medicinal plants, including tulasi. We wanted to find out how we can come out with a best solution to control the disease. Finally, we concentrated on the Terminalia cebula. We call it in South Indian kaduga. It's got an antibacterial property. We dried it. You can see it here, all systematically. Finally, we got a water extract because Muga silkworm is something like that. It rears outside. You have to have something which controls the disease, but at the same time, it should not be toxic to the Muga silkworm. So this extract in water extract, simple way a farmers can take up this. Because we cannot go with, we can't talk about protein and high thing to the farmer. What farmers wanted, they should control the disease, they should get more silk. So this extract was also went for a toxicity study. We found it's an eco-friendly, it's very good and simple technique, the water extract, just sprayed over the leaves. You can see it in the large scale. When we studied in the small scale, we went with the large scale. We got large amount of this Terminalia cebula. You can call the kaduka or helica. We got it from Hyderabad. The forestry department provided. We made it the powder. You can see it here. This was in 2009. This powder, and that time we had another network project with the 3 laboratories are involved, coordinated by Dr. U.S.N. Murthy, currently who is the director of NIPA at Guwahati. He took Assam and Meghalaya, especially to awareness of the recent technique in sericulture to the farmers. So I tried to popularize this product, which is a helica powder, helica extract, which can spray over the plant and that can control the disease, and as well as it can increase the silk production. Almost 10 years. You can see the extract spraying the farmers over the plant. This is the Muga silkworm host plants. Then afterwards, this was again, even now, I had a colleague who did PhD with me currently. He is in the deputy director of the Central Muga Research Institution. This institute came in after the Siri Biotechnology, you can see in 1993. He did PhD with me and he sprayed, even now, this product is being sprayed over the plants by the silkworm. And you can see it here, how much increase in the product. You are getting 35% more silk. Overall, 50% more, less in the mortality. So what I'm going to say, a simple water extract will be very easily, can be prepared by the silkworm farmers, very easily used by the Muga farmers. It can increase the silk production. How? This extract has contained silk, you can say silkworm insect attractants. It contains amino acids, it contains amino sugars, it contains phenolic compounds, algin, etc. And when you spray this extract to the plants. Silkworm eat more food. So as a result, it will increase more silk production. So farmers has got two advantages. I looked for controlling the disease, but farmers has got two advantages. Once it controls the disease as a remedial measure, it can also increase the silk production. When you increase the silk production means that we are increasing their daily bread and butter. So this is what, and ultimately the first time the national level, the Muga silkworm, this work was recognized at the grassroots level. And the first time our laboratory got the Life Sciences Award, especially for this contribution in the sericulture sector in 2011. Next, during this work, when I was collecting the soil around this area, we also found some of the bacterial inoculate, bacterial culture. We call it a plant growth promoting rhizobacteria, which we found, which can also increases the crop productivity, vegetables. So this also, I took it as a small mini project for the student. You can see interesting. This is the Moga host plant. You can see this one is the control, this is the treated plant with the extract, the microbial extract, what we got from the soil. You can see what it does. Now, a little bit of science on that, how it affects. It has got a direct effect. This PGPR, it has also got an indirect effect. At the genetic level, at the molecular level, it can also increases some of the enzymes, which is needed for the plants in terms of chlorophyll synthesis, in terms of plant production, crop productivity concern. Now, this is the tea plant. This is the Muga host plant, which is the control, and this is the tree. You can see the small leaf. All we got it from the microbial material or the substance or the microbial culture, we got it from the soil. You can see the increased level of silkworm larva. You can see it here, tomato plant. We also tried the same microbial extract, but we got it on the plant side. Tomato, this is the lady's finger. This is the control of the late fruiting and the early fruiting. This is also we treated with the tea plants because Northeastern region, you must be knowing Assam, very good for the tea. So my idea with that, whether the microbial extract, what we collected, can be used for all varieties of crops. I tried in success. You can see the less number of leaves in control and the treated one after 30 days, more leaves are coming out. We tried with the rice. You can see the rice here, hardly anything, very few, and here more number of grains. Now these all sort of mini projects, which bought it as a part of the project. We went to the large scale by the farmers there, and they also got a benefit on that. So again, the government aided project, how much it is going to the society. There is a research, how it happened, how the production increased. That's a part of a basic study where a couple of students did the PhD and got the PhD award. Now, the government funded project and outcome utilized substitution. I don't know how many of you knows about that. In 1974-75, we have Ministry of Non-Conventional Energy Sources, Department of Non-Conventional Energy Sources. I started my work the first with a coordinator project funded by Commonwealth Science Council, London. During those days, R.R. Jorhat was coordinating a project on management of water hygiene, which was funded by Commonwealth Science Council. There were 20 disciplines were involved, 7 countries. Now we are talking about multi-institutional, multidisciplinary, but our institute during those days, multi-countries project where I started, how to control the water hygiene. So the main thing is that the controlling of the water hygiene of different forms. Chemistry involved, paper division is involved, biochemistry involved, microbiology. I was more concentrated to utilize the water hygiene for bioenergy. So here, what is bioenergy? Energy produced from any sort of thing where it contains, reduce the fossil fuel. During those days, that time, the money was provided by Ministry of Non-Conventional Energy Sources, and then later on, Department of Non-Conventional. Any sort of a waste, what you found now, plant source, even any sources, you will find cellulose, you will find hemicellulose, you will find lignin. Now, there are 2 ways you can convert these waste. Take an example of water hygiene, aerobic digestion and anaerobic digestion. Anaerobic digestion fermentation, where you can get this in a system where woody biomass anaerobic digestion biomass, energy, digestion residue which comes out, non-pathogenic, it will go directly to the feed. So this is the energy level which from the waste. We tried with the fermentation, again recovery. Now water hyacinth. You will find plenty of water hyacinth during that part. So this water hyacinth, it took about 10 to 15 years of contribution. MNES, DNES, Department of Science and Technology, Northeast Council. We were the nodal laboratory during those times to review the project funded by MNES throughout the India. Now, this we tried, and finally we came up with a, you can see the water hyacinth area. This is the area which was covered previously, water hyacinth, completely taken care of, utilizing the water hyacinth for biogas and for other purposes. Then we came to the digester design. We also made up digester design from 1 liter size fermenter to 10,000 liter. Just 1 liter in the laboratory scale to 10,000. That is what I wanted to give a message to the society, to the people. You should have a project not concentrated on lab to lab. You can see the simple design with a 1 liter size digester where the gas is formed. And then you can see the major digester. You can see the big digester here. This is the floating drum. This is the gas flow. Now the digestion, the material, water hyacinth, everything is inside. And whenever the gas is produced, the floating drums will go up and the gas is measured. This will be supplied. You can see it here. Once we establish the digester, about 10,000 liter, production of about 4,500 liter gas per day, having 50% methane, we provided to our institute canteen as well. Then another problem came during that time. I'm talking about 1980-85, sugarcane press plant. You must be knowing the sugarcane press plant is a waste. The sugar is taken. We took up this challenging. During those times, there was a collaborative project with the FICCI CSIR. We took up the Symbolic sugar mill. That was an example there. We took up the project and finally we made, this is the sugarcane press, this is the sugar, this is the press plant. We came up a large scale biodigester, converting large amount of sugarcane press mud to biogas. And we also could prepare a small mini portable biogas plant to the Nagaland sugar mill. So you can see it here. This is the floating gas holder. This is the gas one. And then the same thing we also use for another substrate. We started with the water hyacinth. We started with the sugarcane press mud for biogas, then waste, de-oil citronella gas. Why I'm telling you all these experiments were done during those days. There is a basic studies, there is an applied work, and finally the outcome goes to the society. This is the citronella gas. When the essential oil is extracted, this plant is waste is being used for the conversion of biogas. You can see a digester here, and you can see a biogas holder. Here there is a gas, the black color one is the gas connection. So the waste which comes from the grass, that is what Dr. Talukdar was telling about the rice, the paddy husk. We also use a mixture of paddy husk with the citronella waste used for the biogas. So we had enough contribution during that time, digested with a floating gas holder, gas meter for measurement. Finally, we also use this gas for the burner. There was special burner. This is, I'm talking about 1980s and 1985 work, which was funded by MNES, DNES, DST, CSC, and Commonwealth Science Council project. Biogas now has been accepted as an attractive, even now people are working on this. KVIC taken up, but the real contribution initiated by RR Jharkhand. This is the first paper came out in 1987. You can see here data based on 1 liter size fermenter to 10,000 liter, having a gas production of 3,500 to 4,000 meter cube meter, the biogas liter. So you can imagine how much contribution has gone to the laboratory level and it has gone to the public. Some people may say that in the research, if you go for societal applied, you cannot get a basic. Yes, you can do it. Most of the basic studies, what is happening in the fermentation, anaerobic fermentation, digestion rate, which factor is responsible for increasing the biogas, everything is done at the laboratory scale. Now, these are some of the best paper came out during those periods. Now, the project funded by for the production of agricultural crop benefiting the people. You must have seen this was the DRDO and DFC funded project, where you can see in the tomato. I'm going to finish within a couple of minutes, very soon. Where what we found, the tomato plant, this was a DRDO funded project to our laboratory in collaboration with the Tejpur, DRDO's sister laboratory, where the tomato always infected by the fungus. We studied the antifungal properties of that, and also to have a control mechanism, how we can stop the fungal infection, the Fusarium oxyphora, that is we found to be, we have identified, we also study the property. Then how to control. So whenever I take any problem, funded project, I have something in my mind, how much you can give the outcome, or you can say as well to the deliverable to the common people, to the farmers. So we try to find out how to control the diseases. We studied large number of medicinal plants. Finally, we concentrated on betel leaf. You can call it in Hindi pan. In South Indian, it is called betela. We just took the betel leaves, extract. We took the extract, and we also studied the components present in that. You can see it here. This betel extract, we have studied with the control plants, you can see, and below the Fusarium infected. This simple extract, dried and picked up in water solution, treated with the plant at a different concentration of this extract. So the biomolecule, bioactive molecule present in the plant, picked up in solutions and then treated with this plant. You can see 0.5, how much infection we controlled, 1% betel extract and 2% betel extract. Then we tried the comparison of the fungus, the control, treated with a different percentage of the fiber extract. You can see the healthy plant, how it is being done. This is even sprayed or treated with the soil and also treated with the tomato seedlings. This is the method, and this outcome has already been patented in collaboration with the DRDO laboratory. Now what happened? He has got the person who did the PhD, Manu Sinha, is there. He has got his good publications. He also got a good invention, a patent, and now the product is also available to the people. And anybody can use this one as simple technology, which is one of the bioresources which is available in the Northeastern part. This is the funded project of my own university. This is also when you say government and private. People may think that how a government funded project can be very well utilized in a private institution. Very well, it is post-established. In fact, Assam Downtown University now has got a research cell. It was established by me during the year 2015 when I retired from the institution, CSIR NIST, and joined there. It is called the research cell. That is, the research cell has done number of activities. This is the one what we have today. We got two major projects. The two projects, it was a consortium mode. The two projects were on scented rice, where lot of information was given by Dr. N.C. Talukdar, black rice and Johar rice. This was a consortium model project where about 35 to 40 laboratories were involved, government institutions and university. Another project was on banana, especially found in the northeastern part of it. Both has got medicinal properties in the health sector. Both can increase both can control the diabetes, cancer, can reduce the cholesterol level. The biomolecule, which is to be found in this rice variety, study. Now, what is happening in one of the projects where currently is the animal studies, that was the Johar rice and black rice. They have found isolated the biomolecule, bioactive molecule, and the human trial studies are going on. Another project, it is still going on, where it has got again the anti-diabetic and anti-cancer property with the banana, different types. You know, they are also studying the vitrotoxicity studies, amylase assay, and also studying the banana pulp powder, hepatoprotective activity, anti-diabetic. Now, through these two projects, Assam Downtown University is linked with 100 research institutions and universities in the countries, funded by Department of Biotechnology. Another project, which is called the foldscope, which is a special type of a simple microscope, and awareness about the use of the microscope at the school-going children. That is very much important as of today. You have to develop the science curiosity, the curiosity inside among the students. You can see a boy here who is making this foldscope and then studying the toxic contaminant which is present in the food, which present in the vegetable, which present in the fruits, banana, maybe apple. So these out of a projects which is the all in hand. Okay, the experiments are being conducted in a simple way at the school going. And part of the project, almost 500 colleges, schools, universities are linked from the Assam Downtown University, linked, again funded by Department of Biotechnology, and awareness program among the school-going students. And the students are also taken up this project for their practical classes. And foldscope can also be used for the early detection of a cancer. Another project where our own faculty, Manis Bora, I always put it in my mind, whenever you have a project, you must have a publication, you must have an innovation pattern, and then the technology. You must have seen, this is the project which is funded by DST through state DST, where he is going to come up with a portable welding machine. You can see it here, low-cost welding machine, lightweight, conveniently transportable, replacement of rivets, keeping all these factors in mind. The main aim of this project is to make joining process easier and also to make popularity of FSW among the small-scale industries, which help in making India project what the Prime Minister has said from the beginning. So this is the project, is an ideal example for publications, academic point of view, outcome of the research, know-how, knowledge, and then it will be commonly people will be used and to the society. So this sort of an idea must be generated, must be had with the investigator before submitting project. This will be the last one. Just I will go through the finally the contribution which given to the society by my own laboratory, CSIR NIS, where I spent almost about 35 to 36 years. You will be very interested to know, even it is in the Jharkhand, serving for 8 states, lot of technologies. They're taking the resources. That is the reason this laboratory was called Regional Research Laboratory. There are 5 regional research laboratories established immediately after independence. Now there are about 39 laboratories spreading all over India. Assam Downtown University has got a MOU with this laboratory since 2015. If you see this, I have picked up few. You will surprise, you will astonish to know that so many technologies, so simple, and most of the research work has gone to the good publication, good pattern in India and abroad, as well as the technology has taken by the people around the country. You can see it here. There are more than 100 technologies. This was for 2017. You can see in the map of India, the black spots. That means the technology developed by CSIR NIS has spread all over India, even from Jammu Kashmir here. These all black spots you will find is the technologies taken by the entrepreneurs. And that laboratory is in Assam, in Jharkhand. So I thought, since I contributed I spent almost 35 years. So this is also a tribute to my former scientists who are no more. They started their career and they are no more, but still the work is continuously going on. And also an idea to the youngest is that how far one can contribute to the society working in a research institute, whether even in a research institute or in a university, it is possible. Starting from the former, the Humayun Kabir, who is no more, Sharma, Jindra Sharma, the Iyengar, these are the directors, Dr. Iyengar, Colonel Mittal, Dr. Tyagarajan, Dr. Jain Barua, Dr. Anil Ghosh, Dr. Sandhu, Dr. P.G. Rao, Dr. Ramayya, then Dr. Chadubadia for some time, and the current director, Dr. Narhari Shastri. So that means the marching towards from these people initiated, still the laboratory, what the objective set by the first director, the first persons of the laboratory for about 60 to 17 years, still following the same pathway serving to the people of the country. You can see some of the technologies here. Lemongrass, improved variety of Jeeva. Very recently, some of the best strains which can give very good production in oil, perfumery industry was transferred through the Prime Minister. Technology transferred to 5 parties. Again, high yielding lemongrass. This is, countrywide, it even importing. All the technology you can see here transferred to 5 parties. Basic research is there. They found why this grass is the best, and the best through the breeding technique. They study the property, and then the technology is immediately transferred. Funded by the government funding. So the government money is given, research is done, the product is developed, given to the society. That is what everyone must have. Now the time has come, not confined to the lab. The MS Swaminathan said once long back, lab to land program. How many laboratories are doing now? We should do it now. That is what. Now, this is a simple one, herbal candid. Now, this will be a very common people who, even the village, if you go through now, even now, they do not have electricity. They do not have a current. Nothing is available. Then now they can study at the same time. As on today, the environment is a lot of mosquitoes. You will find the place where the villagers stay. You can have a candle, light, the poor people can study, children can study. Plus, this will also remove the mosquitoes. 2 advantages, eco-friendly, commonly used by the society. Almost many industries and entrepreneurs have taken. Again, the candles. You can say the herbal incense sticks, technology transferred to 4 parties from Tripura and Assam. Again, the herbal mosquito repellent spray, those who are using in the army, those who are going out, little bit modern, you can spray it and do the work, mosquitoes will go away. All the technology is developed by CSIR NIST. And yet, this is the one which has gone almost about 10 to 15 years of contribution. You have to get permission. People used to say, coming from the medicinal plant, you don't need to find out any side effect. You don't need to go for any toxic. It is totally baseless. Whenever you are bringing any product to the market, you have to see what will happen by use of this product after 10 years. So you have to go with the ethics approval. You have to go with the clinical study. Everything was done. Success, large number of product. We have got our own unit. In 2014, Government of India recognized after about 15 years of contribution of a scientist. And this has now, these products are available now in the market, taken by the companies, different parts at a different name. You can see it here. Even now and today in the Doordarshan or in the channel, you will, because the companies have taken the technology know-how. Money has given to the institute, royalty or whatever it may be. And they are bringing out with their own product with CSIR NIST emblem here. So this is this is for the health sector. Most of the old people, you will get a joint pain. And this is somehow a broad spectrum. Wherever you will find a pain, you can use this product very widely. In fact, some of the places in India, they have taken this, they're marketing the product. This is another fungal product. You can see the hand here, black, the burning, black color, pigmentation in face. You can use this ointment, again, based on the medicinal brand. Technology transferred and exclusively to 5 years to the Kudos India's Limited, New Delhi. You can get it. You may get with a different name, but the know-how, the technology, the research is done by the CSIR NIST. You can see in the animals. Please don't think the work or the research is done only for the human beings. It's not. Even for the animals, for the environment, the phytobioremediation, it is for the environment protection. You can see for the disease, for the product which can be used afterwards, what will have technology ready to transfer. This will be effective against dermal infection, and mostly you will find in the animal system. You can use the product, develop the lab. You can see the beautiful candles, decorative candles produced, simple technology produced by the lab. This is very recently cost effective. You can say the herbal ingredients based on antibacterial hand as on today. That means whenever the need has come, the laboratory has come into that. Very recently, laboratory has also opened a testing laboratory. That is what I said, research based and the need for the people. Whenever the need is there for the society, for the people, laboratory has to come up. This is what, this is what sulfur formulation based on 5 different easily available biomaterial rich in NPK. This is for the field crop improvement. Technology has transferred to one part in Guwahati. This is called TP16. This is also a substitute for synthetic nitrogen urea, a microbe-based. Dr. N.C. Talukdar has said quite a lot. Again, this is the project. Technology has come, product has come, released to their party in Amrit Organic Duliajan. These all products are in the field now. That means utilized by the people and the benefit for the society. This is for the mushroom. In fact, regional research laboratory, once you call it RRL now, any information starting from the beginning, funded by DBT, Department of Science and Technology, CSIR, State DST, lot of contribution they have got. The technology has given to a lot of NGOs have trained. Even this information has gone to outside India as well. This is from the banana fiber, the waste. So you can imagine the simple waste, the simple material. The researchers' input is there, and the outcome has gone to large number of products utilized by the common people. You can see the dustless chalk. That's what I said earlier. You can see that when the chalk is used for writing, you will get a powder. That is not good. If you use it continuously standing near the board, that the dust which comes out, you can say in the nano particle, in the common, the most modern words, it inhale, it goes to the lung. Now this is the chalk, but do not have any dust. Simple one. So this is what, again, the simple technology which has transferred to about 38 parties, and they are bringing the product a different name, but the basic know-how is of CSIR NIST. This is crayon pencils. Again, technology developed by CSIR NIST. See the waste from the paper, waste material, including water hyacinth, we have used for making large number of material disposable, eco-friendly, degradable. That is what you wanted now. Entrepreneurs are taking it, and the technology is available with the CSIR NIST. Then the modular bricks. This is the bricks. This is the sand, which is used from the Brahmaputra river bed sand. This is also a project funded and utilized for because it's a waste. Collected bricks are made. Civil engineering very actively contributing in this area. Collecting the material, field trials are still now going on and used for the construction purposes. Now, any information what I picked up a few because of the time limit. As my parental laboratory, it is my responsibility to say again the word vocal for local. It's a very beautiful word what Prime Minister said. One has to speak from here, whatever I showed. You got an idea, whoever as there in the participant, how much contribution CSIR needs. So any information or others, if you wanted, please contact the address what is flashing now. Any information, anything on technology available on that, you can get it. Now, what I want, recognition, local and indigenous people have their own ecology. It's almost going to be finished my term. Conservation practices, resource management goals has an important implication. It transformed the relationship between biodiversity, Dr. Bhatta, N.C. Talukdar has said, local community. While previously they were perceived simply resource users, indigenous people, now the indigenous people, indigenous information is a part of the environmental management. You have to have a link. Having projects on a number of local aspects relating indigenous and local knowledge and biodiversity, including supporting the intergovernmental platform on biodiversity ecosystem will further improve the quality of life and ultimately benefit the society. Challenges today cut across the traditional boundaries of disciplines. That is, call it a multidisciplinary, multi-institutional, multi-country, and stretch across the life cycle of innovation from research to knowledge, development, and its application. That is the main thing. Science, technology, and innovation must drive our pursuit of more equitable and sustainable development. That is the main message what I wanted to give. This is what everyone, a takeaway message, I always give whenever the talk is over. Each of us, those who are now in the research, I'm still doing it, still in the line, I don't want to go away from the research. but still there are large number of new generation, youngsters are coming. A pledge to protect our country and uplift our society through science and technology that may lead to a healthier environment. That is the main theme of this webinar, the seminar we have heard from for the last 5 days. The ultimate aim, again and again, I'm stressing my point that it must go to the society. It may be a short term, it may be a long term. That is the main aim, should be taken by the new generation of the youngest age who is now in the research. Come out with something after the project outcome which goes to the society. I think, thank you. Thank you very much.
Thank you very much, sir. Such an informative talk. Both Talukdar sir and your talk, I am sure that it will be very much beneficial for our younger people who are very much worried about their future. And if we can spread both these informations in both the talks to the younger people, then it will be highly beneficial. And I'll see how I can spread these things to the young people. And now this session is for discussion. Manas?
Yes, ma'am.
Please take care.
Sir, so we are having questions by, just a second. Pranjit Kumar Bhuya. He's asking that what currently recognized as surrealistic technology approaches, if it were real, could they solve the key problems or global problems of humanity or mankind?
I did not get the questions exactly. He looks like a philosopher.
Okay.
What he mean? What he mean? What sort of a global problem he wanted to solve?
Okay.
Please read the question again.
What currently recognized as surrealistic technology approaches,
Yes.
if it were real, could they solve key global problems of humanity or mankind?
Yes. Simply I have to say yes. If you recognize, certainly. It should be. That is my opinion.
Yes, sir. Okay. So anyway, we are actually running out of time. We are having another meeting from, so we need to wrap, conclude.
Wind up.
Yes, sir. Wind up.
No problem.
Ma'am, you can take over.
Yeah, okay. Now actually we have to start our valedictory session. And first we'll start with a speech by our Chancellor, Dr. Narendra Nath Datta.
Explain.
Manas?
You can play that. I think yesterday they provided, right?
Yeah.
Yeah, it's okay. Yeah.
Sound is not.
Sound
Voice
is not.
yeah. Voice is not there.
Not voice. No.
Voice is not there. Please take care.
Manas, no voice. Not listening. Oh, no. Yes. Yeah, okay. It's coming.
Oh.
Yeah, it's coming. Yeah.
Let's start from the beginning.
Go ahead. Yeah.
For successfully completing the research in public and private institutions and its facilitated webinar. I hope all the participants had a learning experience interacting with the
Yeah,
research
okay.
from Nottingham University, UK, Kyushu University, Japan, IIT Roorkee, Madras, and IIT Guwahati. CSRIR reached Jorhat, University Meghalaya, Jubilant Kempsis, Noida, James Arts and Science College, IAST, Guwahati, and of course Assam Downtown University. I am pleased to see that the webinar could draw participants from different parts of the country and abroad. Research is an integral part of global development and society, and keep the benefits of successful research studies. For academic institutions, it is significant for its sustainability and development. During these 5 days interactive sessions delivered by the expert learned researchers, we must have gained learning on different facets of research. I would also like to congratulate the research cell of Assam Downtown University for taking the initiative to organize the webinar. I would like to invite all of you to visit Assam Downtown University. It is a beautiful site and filled with greenery all around, overlooking the mighty river Brahmaputra. Being the largest educational group of Assam, it has almost 7,000 students. Assam Downtown University will continue organizing similar workshops and seminars at national and international level, and we look forward to your support in our future efforts.
Thank you, sir.
Good afternoon to all the participants. I congratulate.
Thank you, sir, for your inspiring words. Next, speech by our Dean of Studies, Professor Bandana Datta.
Research Cell of Assam Downtown University has organized a seminar on research activities, and the theme of the seminar is really very good. It will help the communities. So I am very happy to we received speakers from England and from Japan, from different institutions of India and Assam also. So I'd like to thank all of them on behalf of Assam Downtown University as a Dean of Studies. I hope this kind of practices will definitely help the participant as well as the other speaker also. So I request our research cell to organize this kind of activities frequently so that you can communicate with the people of different countries and from our own countries also, and you can interact with them. In an academic institution, research has a great role. It can help the societies as well as the communities. But we have to take care of it. After completion of the research, I think we'll be able to find out some solutions which should be spread to the society so that we can use its resources and its usefulness for the development of our community. Once again, I would like to thank the organizers of Assam Downtown University to organize such programs in future also. At last, I request all the participants and the speakers from outside the country or outside state to visit our institution when situations will be given. We will be very happy to host them from our universities. Thank you very much.
Thank you, ma'am, for your inspiring words. Next, I request our chairman of the organizing committee and advisor research Assam Downtown University, Dr. B.Z. Unni sir, to give concluding remarks.
Thanks. I listened the speech by our Chancellor, Dean Madam, and the Vice Chancellor spoke in the beginning. I'm very happy, though I'm not there physically, but the seminar went off very well. The following speakers spoke on different aspects, their areas, thinking, planning, on research contribution. I'm audible?
Yes,
Hello.
yes, sir.
On contributions, their research contributions. However, the ultimate outcome of all the speakers, namely Dr. Narhari Shastri, Dr. Thakuria, Dr. Nayan Sharma, Dr. Hazariga, Dr. Kakoti, Dr. N.C. Talukdar, Dr. Arup Sharma, Dr. S.N. Bora, Dr. Vikas and self were very much within the theme of the webinar seminar, and also given a good message to the youngsters what they should plan before submitting a project proposal to funding bodies. They might have a vision of their outcome from the project that must be beneficial to the society. Thank you very much for your participation in the webinar organized by the Research Cell of Assam Downtown University, and I hope the same will continue further. Thanks to all the participants from different parts of the country and within, in fact, Assam Downtown University and the Northeastern India, outside to the country, for being with us, very patiently listening our speakers' very valuable speech for the last 5 days. Thank you very much for the organizing committee there at Assam Downtown University for spending and making this event one of the very best. Thank you very much.
Thank you very much, sir, for guiding us from the extreme corner of the country. Your support and suggestion will be needed always. Thank you very much, sir. Now, it is time to give vote of thanks. After a 5 days long brainstorming webinar session, now we are in the concluding stage. As a convener of the event, first of all, I would like to thank the Honorable Chancellor of Assam Downtown University, Dr. Narendranath Dutta, Vice Chancellor, Dr. Amar Soti Chaudhary, Dean of Studies, Professor Bandana Dutta, Advisor Research and Chairman of the Organizing Committee, Dr. B.G. Undi, all the members of the Organizing Committee for their suggestion and active support. I would like to thank the distinguished speakers of the webinar for sparing their valuable time to make the webinar a success. We, the member of the Downtown University, feel honored for their presence in the webinar. Their enlightening speech has enriched our thought process. I hope we can have collaborative research with them in near future to address different societal needs. And finally, I thank all the enthusiastic participants of the webinar. Although the speakers from diverse fields have delivered their lecture in different sessions, in every session, a considerable number of participants have taken part. This is very encouraging. I'll be more thankful to the participants if they can engage themselves to research to solve the problem of our society. I am sure the outcome of this webinar will be definitely fruitful. After the corona crisis in the whole world, we are now very much aware about our social responsibility. Synchronizing our guiding research problem and the societal need, we can justify the expense of public money we use to utilize. Thank you very much. And this is the end of the 5 days webinar lecture series.
Thank you very much for the university management for providing the excellent facilities for hosting the webinar so beautifully for the last 5 years. The IT team, in fact, I'm really thankful and appreciated the way they have managed without having any problem, starting from a foreign abroad to India to the extreme corner of the India. Thank you very much.
Thank you.
Thank you, sir. Thank you, everyone.